Okay, guys, we are going to talk through these energy examples. So let's start with the first one. We're going to talk about kinetic energy. So it says, what is the kinetic energy of a 150 kilogram object that's moving at a velocity of 15 meters per second? So let's start there. So we know it's 150 kilograms and it has the velocity of 15 meters per second. So we're going to do 1/2 the mass, 150 kilograms, times the velocity squared. And we have to square the velocity. So when I put this in my calculator, I'm going to do 0.5 because it's the same thing as 1/2 times 150 times 15 squared because you have to square that velocity. So I get my answer to be 16,875, and the units for energy are joules. All right, let's do the next one. It says, what is the kinetic energy of a bike with a mass of 14 kilograms traveling at a velocity of 3.5 meters per second? So again, 1/2 the mass, 1/2 times 14 kilograms times your velocity squared. Will be your kinetic energy. Okay, so 0.5 times 14 times 3.5 squared. I'm going to get 85.75 joules. And we have one more kinetic energy example. On this last one, it says the kinetic energy of a moving car with a velocity of 4.9 meters per second is 19,930 joules. What is the mass of the car? So I already took the formula for you and manipulated it. So we're going to do 2 times the kinetic energy, so 19930 joules. And I'm going to divide that by the velocity squared. And that will give me my mass. So I'm going to do that in parentheses, just like it's written there. So in parentheses, 2 times 19930, close parentheses, divided by parentheses, 4.9 squared, close parentheses. And I'm going to get this big long number, and I'm going to round it as 1,660.14 joules. So this is kinetic energy. You're going to have problems where it's going to ask you to determine if kinetic or potential energy are taking place. If you noticed on these kinetic energy problems, you're given a velocity. Potential energy won't have a velocity because potential energy, things with potential energy are not moving. Things with kinetic energy are moving, so they do have a velocity. So let's look at the potential energy problems. It says a 4,812 kilogram boulder sits atop a 203 meter cliff. What is its PE, or potential energy? So mass times gravity times height. Gravity on Earth is going to be 9.8 meters per second. So that's what we're going to put as the gravity every time. So 4,812 kilograms times 9.8 meters per second times your height of 203 meters will give me my potential energy. 4812 times 9.8 times 203. Woo! This is a big hefty number. It's 9,572,992.8 joules, because energy, again, is in joules. All right, this one says an object that is 905 meters on a ledge has a potential energy of 12,000 joules. What is the object's mass? So this formula has been manipulated for you already, so we're just going to plug in the numbers. So your potential energy was 12,000 joules divided by, in parentheses, gravity times height. So gravity again was 9.8 meters per second. And your height was 905 meters. That's a 5. All right. And that is going to be your mass. So I'm going to do that. 12,000 divided by, in parentheses, 9.8 times 905, close parentheses, and I'm going to get 1.35 kilograms. Your mass will be in kilograms. And then I have one more example for you in this set of examples. All right, it says the potential energy of a 23 kilogram dog on top of a slide is 545 joules. How tall is the slide? So tall would be distance. So potential energy divided by gravity times mass equals height. Oh, I guess the formula says height, not distance. Same thing. It's fine. All right, so potential energy was 545 joules divided by gravity, 9.8 meters per second, times your mass of 23 kilograms. And this is going to give you your height. So 545 divided by parentheses 9.8 times 23, close parentheses, and we get 2.42 meters. All right, there you go. I'll see you guys later. Bye.